Welcome to Sleepy Science. I'm truly delighted to have you with us. You might be winding down after a demanding day, or perhaps you simply find comfort in drifting off while pondering the cosmos, its stars, galaxies, and serene mysteries. Whatever your reason for joining, this journey tonight is yours alone. There are no tasks for you now. Simply allow your body to relax completely, let your mind grow still, and permit your thoughts to float freely. This evening, we venture into the universe in its entirety. We won't focus on any single star or galaxy, but rather embrace the immense, ever-expanding cosmos. We'll transition softly between wonders, from the nature of black holes and the glow of ancient light, to the enigma of dark matter and the allure of distant galaxies. Some discoveries might gently surprise you, while others may linger in your awareness like a half-remembered dream. If this peaceful journey helps you find rest, please feel welcome to like and subscribe. Your support quietly guides others to this haven of calm as well. Whenever you feel settled and ready, we can gently begin our journey. There is no rush. Find a comfortable position, let your breathing become slow and steady, and allow your mind to open to the possibilities of the cosmos. To start, let us contemplate a profound mystery, the age of the universe itself. The story we have long held tells of a universe 13.8 billion years old, a number meticulously pieced together by measuring the faint echo of the Big Bang and watching how quickly galaxies recede from one another. It is a figure that gives our cosmic story a clear beginning. But the universe, in its quiet way, whispers of a deeper, perhaps even longer, past. Scattered throughout the heavens are ancient stars whose advanced age seems to challenge our established timeline. Their very existence suggests they are older than the universe itself is supposed to be, a quiet, persistent paradox. Furthermore, the mysterious force we call dark energy, which drives the cosmos apart, may not be constant. What if it ebbs and flows, subtly altering the cosmic clock? For now, the 13.8 billion year mark remains our guiding star. Yet these lingering questions invite us to wonder, could our universe be far more ancient than we ever conceived? Is it possible that the moment we call the Big Bang was not a true beginning, but simply a turning of the page in a story that started long, long before? A story whose earlier chapters are written in a language we have not yet learned to read. Now let your imagination drift from the universe's beginning to some of its most solitary inhabitants. Picture, if you will, the ultimate wanderers, the rogue planets. Imagine a world untethered, a vast dark sphere of rock or ice sailing on a perpetual silent voyage through the interstellar void. It is a world without a sun, no golden sunrise to warm its frozen surface, no sunset to paint its skies in color. It knows only an endless, star-dusted night. These planets are cosmic orphans. Some were born in the busy neighborhoods of young solar systems, only to be violently cast out by the gravitational pull of their stellar siblings. Others may have condensed alone from cold, dark clouds of gas and dust, like failed stars that never gathered enough mass to ignite. They are the ghosts of the galaxy, almost impossible to see. They reveal their presence only by the most subtle clues. A momentary dimming of a faraway star as they pass in front of it, or a whisper of warmth in the form of infrared light, the last remnant of their internal heat bleeding out into the absolute cold. Astronomers suspect there are more of these lonely worlds in our Milky Way than there are stars, billions of them, each a silent, solitary kingdom. Envision them, these dark spheres spinning slowly in the profound emptiness, their landscapes forever frozen. their skies illuminated not by a sun, but by the faint, unchanging, and distant glow of the entire galaxy. They are a humbling reminder that in the vastness of space, there exists a profound and beautiful solitude. Let your mind wander to the idea that our universe might not have a single story, but an endless cycle. While many scientists believe our cosmos began with a Big Bang and will simply keep expanding, other theories paint a different picture. They imagine a universe that breathes, expanding, then contracting, only to bounce back and begin again. In this view, the cosmos doesn't truly end. It simply resets. Each great cycle might erase the galaxies and stars of the old, yet perhaps faint echoes of the past linger. This is still just a beautiful idea, but it hints that the universe may have no final beginning or end, only an eternal gentle rhythm, with one era giving birth to the next in an infinite loop. Now, let's look at the oldest picture we can see. The most ancient light that reaches us is from a time when the universe was just 380,000 years old. Before that, everything was a hot, thick fog and light was trapped, unable to travel freely. But as the cosmos cooled, a remarkable change occurred. Atoms formed, the fog lifted, and for the first time, light could stream across space. That first light, called the cosmic microwave background, still surrounds us today. It is the universe's oldest baby picture, a faint, cool glow that has been journeying for over 13 billion years, carrying with it the memory of the cosmos in its infancy. Consider, too, the strange and wonderful worlds that might exist. In some distant solar systems, the conditions are so unusual that planets made almost entirely of diamond could form. If a world is rich in carbon and squeezed by immense pressure, its very substance can crystallize. Astronomers have found evidence of such a world, a dense planet orbiting the corpse of a star. While it wouldn't glitter like a gemstone in a jewel store, its interior could be a vast, solid lattice of carbon stretching for thousands of kilometers. These diamond planets are rare, but they remind us that the universe holds wonders beyond our everyday imagination, worlds of rock, of gas, and sometimes worlds of crystal. Let us now turn our minds to the grandest shape of all, the shape of the cosmos. It is a natural human instinct to picture the universe as having a final frontier, a distant edge where everything simply stops. Yet, our understanding of physics paints a far more mysterious and beautiful picture. The universe may, in fact, have no edge whatsoever. It could be truly infinite, stretching forever into a boundless expanse. Or, in a concept that challenges our everyday experience, it might be so immensely vast and curved that it folds back upon itself. Imagine setting out on a voyage in a perfectly straight line, traveling for billions upon billions of years, only to find yourself eventually returning to the very place you began. This is not a journey through space alone, but a journey with space, a gentle eternal loop. The universe, then, may not be defined by endless space, but by an endless, cyclical journey. Now let's bring our gaze closer to home, to our own familiar sun. That steady, golden disk that anchors our solar system may not have always shone alone. It is common for stars to be born in pairs, and our sun was likely no exception. Over 4 billion years ago, within the same swirling nursery of gas and dust, a twin sibling may have ignited alongside it. Through the slow, patient ballet of galactic motion, the two stars would have gradually drifted apart, their bond stretched and finally broken by the Milky Way's gentle, relentless tides. This lost companion, sometimes given the evocative name Nemesis, might still be out there now, a solitary wanderer on a different path through the galaxy, invisible to our eyes. While some have speculated that its gravitational influence could have occasionally stirred the comets in our outer solar system, this remains a captivating theory. The thought itself is a poignant one. Our sun, the constant heart of our celestial family, may once have shared its light with a silent partner, now just another anonymous point of light in the cosmic sea. Finally, let us contemplate one of the most extreme states of matter in the universe, the neutron star. These are not ordinary stars. They are the unimaginably dense cores left behind after a giant star ends its life in a cataclysmic supernova explosion. In that final violent collapse, a star more massive than our sun is crushed into a perfect sphere no wider than a city. The matter within is compressed to a degree that defies all intuition. A single teaspoon of this material would not weigh grams or kilograms, but billions of tons more than every human on Earth combined. A mere droplet of it would be heavier than the entire Mount Everest. Under such incredible pressure, atoms themselves are obliterated, electrons and protons are forced together, merging into a seamless, swirling ocean of pure neutrons. It is a substance of almost raw gravity. These small, dark, and rapidly spinning relics stand as quiet, powerful monuments to the most violent of stellar deaths. A final, dense whisper where a star once roared. Sometimes the light from a single faraway galaxy can appear to us in several places at once. This happens because the path of light can bend. When light travels through space, it follows the shape of the universe. In places with immense gravity, like near a cluster of galaxies, this shape is warped, acting like a lens. This phenomenon, called gravitational lensing, can create multiple images of the same galaxy as faint arcs, smears, or even perfect rings of light. These aren't different galaxies, but different portraits of the same one as its light has taken separate, long journeys around the cosmic curve. On rare occasions, astronomers have even seen the same star explode multiple times, as each flash of light found a different route to our telescopes. It shows us that in the cosmos, light can wander, taking scenic paths, yet still arrive to tell its story. Now, let's travel back to the very first stars. These pioneers, known as population the third stars, were nothing like the stars we see today. Formed from only the simplest elements, hydrogen and helium, they grew to be colossal, some hundreds of times more massive than our sun. They were incredibly hot and brilliant, burning 1,000,000 times brighter than the sun. But such intensity came at a cost. They consumed their fuel in just a few million years, ending their short lives in giant explosions. Though they are long gone, their legacy is all around us. In their fiery deaths, they forged the first heavy elements, filling the early universe with the building blocks for future planets and life itself. Their light has faded, but the seeds they planted would one day grow into everything we know. Finally, consider something invisible that is with you right now. As you rest, a silent river of dark matter flows through you. It is not a ghostly fog, but a mysterious substance that does not interact with light at all. We cannot see it, touch it, or feel it, yet it has gravity, and it is essential. Our galaxy is embedded within a huge sphere of this dark matter. As our planet moves, countless dark matter particles pass through every part of you every second. They leave no mark, but they are always there. Without the gravitational pull of dark matter, galaxies would fly apart, and the universe would look entirely different. We still do not know what it is, but we know it is a fundamental part of our world, an unseen presence that moves through you even in your deepest sleep. In the deep quiet of space, there are galaxies that glow with a mysterious light, yet they hold almost no stars. These faint, ghostly islands are rich with gas and dark matter, but for reasons we don't yet understand, they have failed to create new suns. Perhaps they lost their stars long ago in a cosmic encounter, or maybe they never truly began to shine. They appear only as the faintest smudges in our most powerful telescopes. These dim galaxies are a quiet puzzle, challenging our ideas of how a galaxy should live. They drift in the darkness, unanswered questions reminding us that not all galaxies are brilliant cities of light. Some are simply quiet, shadowy worlds. Elsewhere in the cosmos, there is a mystery known as the cold spot. In the ancient afterglow of the Big Bang, the universe's first light, there is one area that is unexpectedly and profoundly cold. This region is not just a little chillier, it is a vast cosmic cold patch stretching across hundreds of millions of light years. Its existence doesn't fit neatly with our models of the early universe. Some scientists suggest it might be the shadow of an immense empty void. Others wonder if it could be a scar from our universe brushing against another. For now, no theory perfectly explains it. The cold spot remains a gentle, persistent whisper that there is still so much we have yet to understand. And our own moon is engaged in a slow, graceful departure. Each year, it moves about 3.8 centimeters farther from Earth, a distance no greater than the width of your fingernail. This gentle retreat has been happening for billions of years. In its youth, the moon was much closer, and an Earth day was only a few hours long. The push and pull of our planet's tides act like a gentle brake, slowly transferring energy and nudging the moon into a wider orbit. It is a process too slow for us to perceive, but over cosmic time, its effect is profound. One day, Earth and the moon will be locked in a silent embrace, each always showing the same face to the other. For now, our companion continues its slow, silent drift into a more distant future. Imagine two stars so close that they dance in each other's embrace. In these intimate pairs, known as binary stars, their outer atmospheres can gently touch. As they age, one star may expand and begin to share its material with its partner in a slow cosmic exchange. This transfer can be a peaceful flow, or it can spark brilliant flashes of light and cause the stars to spin wildly, sometimes ending in a complete merger. It's a complex dance, but a beautiful one. Two stellar partners so close they become intertwined. One may be left as an exposed, glowing heart, while the other grows larger from the gift. Their destinies are forever linked, and from these quiet, touching pairs, some of the universe's most exotic objects, like certain supernovae or pairs of neutron stars, are born. It shows us that even in the vastness of space, connection can lead to profound change. Now, consider the emptiness of space. What we perceive as a perfect vacuum is not truly empty. According to the rules of quantum physics, even the deepest, darkest void is a hive of subtle activity. Tiny pairs of particles and their opposites spontaneously flicker into existence for the briefest moments before vanishing again. This constant, quiet shimmer of energy is part of the fabric of reality itself. It influences how particles move and is even thought to contribute to the mysterious force we call dark energy, which is causing the universe to expand faster. So, while space may seem silent and still to us, it is in fact filled with a low humming dance of creation and annihilation, just beneath our perception. Finally, let's think about time itself. We often imagine it as a steady universal river flowing at the same rate for everyone. But Einstein showed us that time is flexible. It is woven together with space and is shaped by gravity and motion. Where gravity is stronger, like near a black hole, time actually moves more slowly compared to places with weaker gravity. This isn't just an idea, it's a measured fact, confirmed by precise clocks on satellites. Some scientists even speculate that time might flow at different rates in different, vast regions of the cosmos due to the universe's explosive beginning. While this is still a theory, it opens up a fascinating possibility that time is not absolute, but is a gentle, variable current, quietly bending to the shape of the cosmos it flows through. Let us turn our attention to our celestial home, the Milky Way. When we gaze at a picture of our galaxy, we see a magnificent luminous spiral, a whirlpool of billions of stars, dust, and gas, all gracefully orbiting a brilliant core. But this breathtaking image is only the heart of a much larger and largely invisible entity. Enveloping this familiar disk is an immense spherical cloud known as the galactic halo. This vast, ghostly structure is composed of wisp-thin gases, mysterious dark matter, and some of the most ancient star clusters in existence. It extends for hundreds of thousands of light years in every direction, a colossal sphere of influence that dwarfs the bright disk at its center. We cannot see this halo directly, but we feel its presence in the subtle, unwavering pull of its gravity, a force that guides the motion of visible stars and gently warps the very fabric of space, bending the light from distant objects as it passes through. So when you next look up at the starlit band of the Milky Way, remember that you are seeing only the glowing core of a far greater unseen being, a luminous heart beating within a vast dark body. Now, let us journey back to the very dawn of time. With the incredible power of the James Webb Space Telescope, we have recently captured a whisper from the universe's infancy, the light from a galaxy that flickered to life when the cosmos was a mere 200 million years old. Because light, for all its speed, takes time to cross the unimaginable voids of space, we are not witnessing this galaxy in its current state. We are receiving a message from its past, a snapshot frozen in time from over 13 billion years ago. This faint, ruddy glow emanates from one of the very first assemblies of stars, a small, primordial structure that was among the first to ignite and push back against the pervasive darkness of the early universe. To observe it is to peer through a narrow keyhole into the deepest past, to witness the universe in its childhood, just taking its first tentative steps toward the complexity we see today. It is a direct look at our own cosmic origins, a single, quiet frame from the very first chapter of creation. Finally, let us pull back our perspective to the grandest scale imaginable. When astronomers map the positions of countless galaxies across the cosmos, a breathtaking and strangely familiar pattern emerges from the chaos. The universe is not a random scattering of lights. Instead, galaxies are gathered along immense, thread-like tendrils, forming a structure of unimaginable scale known as the cosmic web. These brilliant filaments, woven from the gravity of both light and dark matter, connect at dense nodes where thousands of galaxies swarm together in massive clusters. And between these strands of light lie the great cosmic voids, regions of profound emptiness so vast that they span hundreds of millions of light years. This entire intricate structure, the largest known in existence, bears an uncanny and beautiful resemblance to the neural network of a human brain, with its dense clusters of galaxies acting like neurons and the long filaments like connecting axons. Of course, this is merely a structural echo. The universe is not a conscious mind, but it is a quietly profound and humbling thought that the architecture of the entire cosmos and the intricate wiring within our own skulls should share such a similar, beautiful, and intricate design, as if the same fundamental pattern of connection repeats itself from the vastness of space to the intimacy of our own thoughts. Though sound cannot travel through the empty vacuum of space, stars have their own way of making music. They resonate with deep rhythmic pulses vibrating much like a planet trembles during an earthquake. Scientists study these quiet stellar heartbeats through a field called astroseismology. By watching for tiny changes in a star's light or its surface, they can detect these internal vibrations. Each star hums with a unique set of frequencies, a sonic fingerprint that reveals its hidden inner life, its size, its structure, and its age. It is a form of cosmic listening, allowing us to hear the silent song of a star from light years away. In the great cosmic dance, some stars are older than the galaxy they now call home. Galaxies are not born fully formed. They grow over billions of years by merging with smaller galaxies and absorbing their stars. This means that within a large galaxy like our Milky Way, there are ancient stars that were born elsewhere, in smaller, long-vanished systems. These stellar elders, often found in the outer halo or in dense globular clusters, can be nearly as old as the universe itself. They are living fossils, their simple chemical composition telling the story of a younger, purer cosmos. Their light carries tales from a time before the galaxy, as we know it, even existed. One of the most puzzling recent discoveries is the existence of galaxies that appear to have no dark matter. For decades, we have believed that dark matter is the invisible scaffold of the universe, the glue that holds galaxies together with its gravity. But a handful of galaxies defy this rule. Their stars move in ways that can be explained by visible matter alone. This finding was a complete surprise and challenges our fundamental understanding. Some theories suggest these galaxies had their dark matter torn away in past collisions. Others hint that our concept of dark matter itself might need rethinking. These mysterious galaxies are a quiet reminder that the universe is still full of secrets, and even our most basic assumptions can be gently called into question. Let us bring our attention closer to home, to the warm, life-giving heart of our solar system, the Sun. We see it as a steady, brilliant disk, but if we could perceive its true nature, we would witness a celestial body in constant, resonant motion. Deep within its nuclear furnace, powerful sound waves are born. Not the sound we know, but deep, subsonic pressure waves that ripple through the searing plasma. These vibrations cause the entire star, from its core to its corona, to rhythmically pulse and swell, as if it were a colossal, slowly ringing bell. This is a silent symphony, its frequencies far too low for human ears, playing on a scale almost too vast to comprehend. Yet through the delicate science of helioseismology, we have learned to listen. By observing the subtle rhythmic brightening and dimming of the Sun's surface, scientists can detect these profound oscillations. It is a form of cosmic echolocation. By deciphering this resonant song, we can peer into the Sun's hidden depths, mapping its inner structure, measuring the churning rivers of superheated gas that flow within it, and understanding the differential rotation of its layers. Our Sun, in its eternal and silent performance, teaches us the inner workings of stars across the universe. It is a vast, complex, and living instrument, forever humming a deep, resonant tune that holds the secrets to its own fiery soul. Now, let us expand our view to the grandest design of all, the architecture of the cosmos. If we could step outside our universe and see it in its entirety, we would not see a random scattering of galaxies. Instead, we would behold an immense and beautiful web, a cosmic tapestry woven from filaments of breathtaking scale. Galaxies, including our own Milky Way, are not isolated islands. They are strung along these luminous threads like precious jewels on an endless necklace. But the most profound truth is that these brilliant strands are merely the decoration, the visible trace of a far deeper reality. The true framework of the universe is built from something we cannot see, the mysterious, invisible substance we call dark matter. This hidden skeleton, this cosmic scaffolding, dictates the shape of everything. We know it is there because we can see its gravitational signature. The way galaxies obediently cluster along its lines, and the way its immense mass warps the path of light from objects behind it, a phenomenon known as gravitational lensing. These dark filaments connect vast superclusters of galaxies across hundreds of millions of light years, while between them lie the great cosmic voids, regions of stunning emptiness and quiet. This invisible architecture, whose true nature remains one of the greatest unsolved mysteries in science, is the quiet, guiding hand that has shaped the visible universe from its very beginning. Finally, let us contemplate one of the most mind-bending principles of cosmology, one that challenges our very understanding of motion and distance. There is a fundamental speed limit in the universe, the speed of light. Nothing that moves through space can exceed this cosmic velocity. However, space itself plays by a different set of rules. Space is not a static stage. It is a dynamic, stretchable fabric. And this fabric can expand, and it can do so at any speed it wishes. In the first fleeting instance after the Big Bang, space underwent a period of ebb inflation, expanding faster than the speed of light, seeding the vastness we see today. And this process has not stopped. The universe continues to stretch. This is the key to understanding our receding cosmos. Those distant galaxies are not rocketing away from us through space like shrapnel from an explosion. Instead, the very space between us and them is continuously growing like the surface of an inflating balloon. The galaxies are merely passive riders on this expanding fabric. For the most distant galaxies, the cumulative stretching of the space between us is so great that they are carried away from us faster than light. This means their light, no matter how bright, can no longer cross the ever-widening gulf. They have passed beyond our cosmic event horizon, fading from view not with a bang but a whisper. It is not a violent expulsion, but a calm, relentless, and inevitable drifting apart, a gentle farewell written into the fundamental laws of reality, forever carrying islands of creation beyond the horizon of our perception. Our solar system is on a grand spiraling journey. We often imagine the planets simply circling the sun, but a wider view reveals a more beautiful motion. The sun itself is traveling at immense speed around the center of our galaxy. As it moves, it pulls all the planets along with it. Together, we trace a gentle corkscrew-like path through the cosmos, like a twisting ribbon flowing through space. Nothing in the universe is truly still. Even as you rest, you are part of this slow, graceful spiral, a quiet cosmic dance on a scale too vast to feel. In the deepest, darkest voids between galaxies, where there seems to be nothing at all, there is still a faint warmth. The temperature of empty space is just a few degrees above absolute zero. This gentle heat is the last remnant of the Big Bang, an ancient light called the cosmic microwave background. After billions of years of expansion, this energy has cooled into a faint, universal glow that permeates every corner of the cosmos. It is the lasting echo of the universe's fiery birth, a whisper of heat that will slowly fade over trillions of years, but never completely disappear. The immense structure of our universe may have begun with the tiniest of tremors. At the most microscopic level, empty space is not calm. It flickers with tiny random fluctuations, particles and energy blinking in and out of existence. Scientists theorize that in the first split second after the Big Bang, a period of incredibly rapid expansion called inflation stretched these quantum ripples to an enormous scale. These tiny random variations became the blueprints for everything to come, the gravitational seeds that would one day grow into galaxies, stars, and planets. In a very real sense, the entire cosmic web we see today may have grown from the faint, unpredictable trembling of nothingness. Some stars do not end their lives in a sudden explosion, but with a slow and rhythmic pulse. In their final stages, these aging stars, known as variable stars, gently swell and shrink in a steady, repeating cycle. This change in brightness is like a long, slow heartbeat caused by their outer layers of gas expanding and contracting. Some complete this cycle in days, while others take years. Astronomers use the reliable rhythm of these stars to measure vast distances in space. They are a peaceful reminder that even in their fading moments, stars can mark time with a deep cosmic breath. If we could see the universe in a different light, we would discover that our solar system rests inside an enormous, glowing cavity called the local bubble. This vast region, stretching hundreds of light years across, is filled with thin, hot gas. It was created long ago by the force of ancient supernova explosions, which cleared away the denser material and left this quieter space behind. Our sun and its planets now drift peacefully through this cosmic chamber, surrounded by a shell of warmer gas and dust, a gentle, invisible reminder of violent events from the distant past. Our galaxy is part of a slow cosmic migration drawn toward a mysterious region of immense gravity known as the Great Attractor. But the pull we feel is only half the story. Lying in the opposite direction is an equally powerful force, an enormous, nearly empty region of space called the dipole repeller. This vast cosmic void, spanning hundreds of millions of light years, has so little matter that it effectively pushes galaxies away from it. The motion of our Milky Way is shaped by this quiet tug of war, pulled by the unseen mass of the Great Attractor and pushed by the profound emptiness of the void. It shows us that in the universe, both what is there and what is missing can guide our journey. At this very moment, trillions of invisible particles called neutrinos are streaming through your body. They come from the sun, from dying stars, and from the ancient universe. These ghostly particles are so light and elusive that they can pass right through our entire planet and through you without a single interaction. While special detectors deep underground can occasionally catch one, the vast majority simply journey on, silent and unseen. They are a constant, gentle rain, moving at nearly the speed of light, reminding us that the universe is always in motion, even in apparent stillness. Not all stellar deaths are spectacular explosions. The very largest stars can meet a much quieter end. When such a colossal star exhausts its fuel, its own gravity can be so overpowering that the entire star simply collapses inward all at once. There is no supernova flash, no brilliant finale. In an instant, the star vanishes from sight, leaving behind only a black hole. Astronomers have watched stars simply wink out of existence, a silent reminder that some of the universe's most dramatic transformations happen without a sound. Galaxies are not lonely giants. They often exist in families. Our own Milky Way is orbited by dozens of smaller satellite galaxies, the most famous being the Large and Small Magellanic Clouds. These companion galaxies circle our own in a slow, graceful dance that takes billions of years. In this gentle cosmic ballet, the larger galaxy can slowly draw stars away from its smaller partners, creating beautiful, flowing bridges of light. Over eons, a small galaxy may be entirely absorbed. It is a quiet, majestic process, showing that even on the grandest scales, nothing in the universe is truly alone. Some of the most brilliant flashes in the cosmos come from a special kind of star known as a magnetar. These are the dense, spinning cores of dead stars possessing magnetic forces trillions of times stronger than Earth's. On rare occasions, a magnetar can release a cataclysmic burst of energy called a hyperflare. In just a few seconds, this event can outshine an entire galaxy, producing a long-lasting pulse of high-energy gamma rays that travels across the universe. It is a brief, unimaginably powerful firestorm born from the violent collapse of a star wrapped in immense magnetic power. When we talk about the edge of the universe, we are really speaking of the limit of our own sight. The observable universe is a sphere around us extending about 46 billion light years in every direction. This is not a physical wall, but simply the farthest point from which light has had time to reach us since the beginning. The true universe almost certainly continues far beyond this horizon, because space itself is expanding at an accelerating rate. The light from the most distant regions will never be able to cross the growing void to reach us. Our view of the cosmos is like a bubble. Outside of it lies a reality we can know exists, but will never see. In the centers of many galaxies, supermassive black holes act as powerful engines. As vast amounts of matter spiral inward, not all of it is swallowed. Some is captured by intense magnetic fields and funneled into narrow jets that blast outward at nearly the speed of light. These jets of superheated plasma can travel for millions of light years, stretching far beyond their home galaxy and glowing brightly in radio waves. It is a profound contradiction. From the edge of a void from which not even light can escape, some of the largest and most brilliant structures in the universe are born. In our galaxy, most stars travel together in the same direction like a vast flowing river of light. But astronomers have found at least one star that goes its own way, moving in the opposite direction against the galactic current. This stellar rebel may be a visitor from a smaller galaxy that was absorbed by the Milky Way long ago, forever carrying the signature of its original home. Or it might have been sent on this unusual path by the powerful gravity of a black hole or dense star cluster. This solitary traveler is a gentle reminder that even in the orderly dance of the cosmos, there are always individuals who follow their own unique path. If you could smell the giant dust cloud at the heart of our galaxy, you might detect the surprising scent of raspberries and rum. This isn't a fantasy. Scientists have discovered a molecule there called ethyl formate, which on Earth gives raspberries their flavor and contributes to the aroma of rum. Of course, in the airless vacuum of space, there is no smell to perceive. But the presence of this molecule, along with sugars and the building blocks of amino acids, reveals that the raw ingredients for complex chemistry, and potentially even life, are being crafted in the silent darkness between the stars. A grand cosmic encounter is already underway. Our Milky Way galaxy and its neighbor, the Andromeda galaxy, are slowly but surely moving toward each other. Although Andromeda is currently 2.5 million light years away, the immense invisible halos of gas and dark matter surrounding both galaxies have already begun to gently overlap. In about 4 billion years, they will start to merge in a slow, majestic dance. This will not be a violent crash, but a graceful blending, as stars are so far apart that they will simply pass by one another. Over eons, the two majestic spirals will coalesce into a single larger galaxy, sometimes nicknamed Milkdromeda. This cosmic reunion, set in motion billions of years ago, continues its patient, unfolding course. The space around you is not completely dark. It is filled with a faint, ancient glow known as the cosmic microwave background. This is the leftover light from the Big Bang, released when the universe was a mere 380,000 years old. At that moment, the hot, dense cosmos cooled just enough for light to break free and begin its journey across the ages. That primordial light has been traveling ever since, stretched by the expansion of the universe into a soft whisper of microwaves that permeates all of space. It is the oldest picture we have of the universe, a gentle echo from its very beginning that still surrounds us today. Not all stellar deaths are brilliant explosions. Some massive stars meet a much quieter end. In what astronomers call a failed supernova, a star's core collapses under its own gravity to form a black hole. But instead of erupting in a spectacular flash, the star's outer layers simply fall inward, vanishing silently into the new darkness. In these rare cases, a star that was shining brightly one moment can simply disappear the next, leaving no visible trace. It is a reminder that the most dramatic transformations in the cosmos can sometimes happen in complete silence. Not every galaxy is a blazing city of stars. Some are faint, shadowy realms made mostly of gas and dark matter, with very few stars to light them up. These dim galaxies are difficult to see and often appear only as faint smudges in our most powerful telescopes. They may be cosmic experiments that never quite succeeded in making stars, or perhaps they lost the material needed long ago. Unlike their bright spiral cousins, these galaxies do not announce their presence with light. They exist as quiet, gravitational ghosts, reminding us that a galaxy can have a powerful presence without ever learning to shine. When two black holes find each other in the void, they begin a slow spiraling dance. As they circle closer, they send out ripples in the very fabric of space and time, known as gravitational waves. These waves carry energy away, causing the black holes to draw ever nearer until they finally merge into one. This cosmic event creates no flash of light, but it sends a powerful tremor through space-time that we can now detect with special instruments on Earth. The first such signal was captured in 2015, proving a prediction Einstein made a century ago. Each new detection tells the story of an invisible collision in a distant galaxy, a moment where the universe itself resonates with a silent, powerful chord. Not all stars meet a swift end. A star like our sun will fade away over an immense span of time. After it expands into a red giant, it will gently shed its outer layers, leaving behind a hot, dense core called a white dwarf. This Earth-sized ember no longer creates new energy, but simply glows with its remaining heat. It will take billions of years for a white dwarf to slowly cool and fade to black. In fact, the universe is not yet old enough for any to have fully dimmed. Every white dwarf that has ever existed is still in the process of a long, quiet farewell, like a single coal from a fire cooling in the dark over eons. Near a black hole, time itself behaves in a strange way. Einstein's theory tells us that gravity does more than pull on objects. It actually warps time. Where gravity is strongest, time moves more slowly. Near the immense gravity of a black hole, this effect is extreme. If you could hover just at its edge, time for you would crawl compared to the flow of time on Earth. What felt like minutes to you could be years for everyone else. This isn't just a theory. We measure a smaller version of this effect with the atomic clocks on GPS satellites. In a sense, a black hole doesn't just capture light and matter, it captures time, stretching a single moment into an eternity. The deepest, darkest spaces between galaxies are the coldest places we know. Far from any star, the temperature in these vast voids plunges to just a few degrees above absolute zero. This is colder than any natural environment on Earth, and even beyond what our most advanced labs can typically achieve. This profound chill exists because these regions are almost perfectly empty, with very few particles to hold any warmth. They are immense, silent deserts, stretching for millions of light years, where the only energy is the faint, leftover glow from the birth of the universe. Over its long life, the universe has been slowly clearing its own haze. In its earliest moments, the cosmos was a dense hot fog that trapped light, preventing it from traveling far. But after about 380,000 years, it cooled enough for atoms to form, and this fog lifted. This moment, called recombination, allowed light to stream freely for the first time, creating the ancient glow we now call the cosmic microwave background. Since that pivotal event, the universe has continued to become more and more transparent. As matter has spread out across the expanding cosmos, light finds fewer and fewer obstacles in its path, allowing it to journey across vast, clear distances. In a monumental scientific achievement, we have taken a picture of a black hole's shadow. In 2019, a global network of telescopes, working together as one Earth-sized instrument, captured an image of the supermassive black hole at the heart of the galaxy M87. We cannot see the black hole itself, but we can see its dark silhouette, the point of no return, set against a brilliant swirling ring of superheated gas. This glowing halo is created by matter being twisted and compressed by the black hole's immense gravity. This historic image was not an artist's rendering, but a direct observation, a quiet and profound moment where we looked into the darkness and saw the unseeable. On a clear, dark night, far from city lights, you can gaze up and see another galaxy with just your eyes. The Andromeda Galaxy appears as a soft, fuzzy patch of light in the sky. It is incredibly distant, over 2.5 million light years away, meaning the light that reaches your eyes began its journey long before humans walked the Earth. This faint smudge contains 1 trillion stars, and it is slowly, steadily drifting toward our own Milky Way. It is a humbling thought that you can witness an entire island universe, vast and ancient, with no tool but your own sight. In 2015, a sensitive observatory on Earth heard a whisper from the distant cosmos. It detected a tiny ripple in the fabric of space itself, caused by 2 black holes colliding more than 1 billion light years away. These gravitational waves are so faint that they stretch and compress space by a distance smaller than a single proton. Yet, with incredibly precise instruments, we can now listen to these quiet tremors. This confirmed a prediction Einstein made a century ago, proving that the most violent events in the universe send out silent waves that we, on our small planet, can now perceive. As the universe expands, it is also carrying parts of itself away from us forever. The space between galaxies is stretching at an accelerating rate. For some of the most distant galaxies, this expansion is so fast that their light will never be able to cross the growing void to reach us. They have already slipped beyond our cosmic horizon. This means that over billions of years, more and more of the universe will simply fade from our view. The cosmos is not just growing, it is also gently releasing parts of itself into a permanent and silent solitude. Most black holes are the remains of dead stars, but some might be relics from the very beginning of everything. These are called primordial black holes, and they could have formed from tiny, dense knots in the hot, newborn universe long before the first star ever ignited. They could be almost any size, and while we have never found one, their existence might solve great mysteries. They could be part of the dark matter that holds galaxies together, or they could have been the seeds from which the first galaxies grew. If they are real, they would be the universe's oldest artifacts, silent remnants from the first moments of time. In the quantum world, 2 particles can become linked or entangled in such a way that they share a single existence, no matter how far apart they are separated. A change to one is instantly reflected in the other, creating a profound connection that seems to defy distance. This doesn't allow for faster than light communication, but it reveals a deep, invisible interconnectedness woven into the fabric of reality. Some scientists believe that particles entangled during the Big Bang could still be linked today, creating a subtle web-like structure that stretches across the entire cosmos, a silent quantum memory of the universe's origin. What we think of as empty space is not truly empty. At the tiniest scales, The vacuum of space is a seething sea of activity where particles flicker in and out of existence. This constant low-level turmoil creates a kind of background pressure known as vacuum energy. This energy is thought to be the source of dark energy, the mysterious force that is causing the universe to expand at an ever-increasing rate. Unlike matter or light, this energy does not get weaker as the universe grows. Its push remains constant. In a strange way, the apparent nothingness of empty space possesses a gentle but relentless force that is quietly pushing the cosmos apart. Even black holes, known for their immense gravity from which nothing can escape, are not entirely eternal. A theory developed by Stephen Hawking suggests they can slowly lose mass by emitting a faint form of energy, now called Hawking radiation. At the very edge of a black hole, the turbulent nature of space allows particles to escape, carrying away a tiny amount of energy. This process is unimaginably slow. A black hole with the mass of our sun would take trillions of times longer than the current age of the universe to evaporate. Rather than a dramatic explosion, its end would be a quiet and gradual fading, a long, slow sigh into nothingness. While we are most familiar with solids, liquids, and gases, the most common form of visible matter in the universe is actually plasma. This is a superheated, electrically charged gas where atoms are broken apart into their constituent particles. Plasma is what stars are made of, and it fills the space between them, flowing as solar wind and glowing in vast nebulas. It responds to magnetic forces and can conduct electricity across the emptiness of space. On Earth, we see it in lightning and neon signs. But beyond our world, it is the fundamental state of almost all visible matter, silently shaping the cosmos. The force of gravity can create ripples that travel through the universe. When incredibly dense objects like black holes or neutron stars collide, they create waves in the fabric of space-time itself. These gravitational waves travel outward at the speed of light, subtly stretching and squeezing everything in their path. For a long time, these waves were only a theoretical prediction, but we have now built instruments sensitive enough to detect them. Each ripple we capture tells the story of a distant cosmic event, carrying information about the masses and spins of the objects that created it. Though completely silent and invisible, these gentle shudders allow us to feel the echoes of the most powerful events in the cosmos. If we could step back, far beyond the confines of our own galaxy and view the cosmos from a godlike perspective, the true majesty of its structure would be revealed. We would see that the universe is not a chaotic splatter of stars, but a work of art, a vast, three-dimensional tapestry of breathtaking order and scale. This is the cosmic web, the fundamental architecture of all existence. Galaxies, from the great spirals to the faintest dwarfs, are not scattered in isolation. They are drawn together, like pearls on a string, along immense, winding filaments that stretch across the unimaginable void. These filaments are woven from the gravitational influence of dark matter, the invisible skeleton that gives the universe its shape, and traced by faint rivers of primordial gas. At the intersections of these great cosmic highways, we find the metropolises of the universe, dense clusters where thousands of galaxies swarm in a gravitational dance. And between these brilliant, bustling strands lie the voids, regions of profound and haunting emptiness so vast they could contain thousands of galaxies, yet hold almost none. This is the grand design, a universe structured like a neural network, a sponge, or the frost on a window pane. A pattern that emerges with mathematical elegance from the gentle, relentless pull of gravity, weaving light and matter into a web of unimaginable beauty and scale. The James Webb Space Telescope is not merely a new instrument. It is one of humanity's greatest time machines. Unlike any machine from fiction, it does not travel through time, but rather it patiently waits for time to come to it. Every photon that strikes its golden mirrors is a messenger from the distant past. Because the speed of light, for all its incredible velocity, is finite. To look deep into space is to look far back in time. When Webb peers into the void, it captures the light of infant galaxies that has been traveling for over 13 billion years. The galaxies in its most profound images are not as they are now. In the billions of years it has taken their light to reach us, they have likely undergone dramatic transformations, merging with neighbors, ceasing their star formation, or being reshaped by cosmic collisions. We are not seeing their present reality, but a ghost image, a luminous echo of their youth. Every deep field photograph from Webb is therefore a gallery of cosmic ghosts, a collection of portraits of celestial objects that may have long since faded or evolved into something entirely new. It allows us to browse a family album of the universe, filled with pictures from its earliest childhood. And this leads us to a final, humbling thought. Every time you look up at a star-filled night, you are not just looking out into space, you are gazing back through the corridors of deep time. When you observe a galaxy millions or billions of light years away, the light that enters your eye is ancient. It began its journey long before our Earth had even coalesced from the cosmic dust, before our sun was a flicker in a nebula. You are witnessing events that transpired in the universe's primeval past. The individual stars whose combined light you see as a soft, hazy smudge may have lived their brilliant, short lives and expired in spectacular supernovae billions of years ago. Their stories of birth, life, and cataclysmic death are only now arriving, a delayed broadcast on a cosmic scale. The night sky is not a static painting. It is a living, dynamic chronicle. It is a tapestry woven from threads of different eras, a collage of the past. The tranquility of the stars is an illusion. It is the quiet of a museum where every exhibit tells a story from a different epoch. So, as you rest, remember that the darkness above is filled with the gentle, persistent whispers of a past so deep and so vast. It contains the very secrets of our own origin. As you rest here, safe and still, you are a part of a silent, ceaseless interaction with the depths of the cosmos. Our planet is continually bathed in an invisible rain, a gentle shower of visitors from the farthest reaches of the galaxy and beyond. These are cosmic rays, subatomic particles, the shattered fragments of atoms, hurled across the void by the most violent events the universe can conjure, the cataclysmic fury of supernovae, and the unimaginable gravitational whirlpools surrounding black holes. They travel at velocities approaching the speed of light, a silent, hyper-fast hail against the roof of our world. Most are deflected by the protective magnetic cocoon of Earth's magnetosphere or harmlessly absorbed by the blanket of our atmosphere, creating the beautiful, ethereal glow of the auroras in the polar skies. But a persistent few, make it through. At this very moment, these tiny messengers are passing through the air around you, through the walls, and even through your own body, leaving no trace or sensation. They are, for the most part, utterly harmless, but their presence is a profound and quiet reminder. We do not exist in a sterile, empty box. The space between the stars is alive with motion and energy, a dynamic medium through which these silent physical messages travel for millions of years, connecting us, in the most intimate way, to the most distant and powerful events in the universe. Now, let your mind drift to the ultimate question of origins. We speak naturally of the Big Bang, and our minds conjure an image of a titanic explosion in a pre-existing void. But this image is a profound simplification. In our current understanding, rooted in Einstein's theories, the Big Bang was not an explosion in space and time. It was the simultaneous emergence of space and time. There was no outside, no before for the explosion to happen in. The very concepts of where and when were born in that initial singular moment. To ask, what happened before the Big Bang, may be a question that the universe, by its very nature, does not permit us to answer. It is akin to asking what lies north of the North Pole. The question itself uses a framework, direction, that breaks down at that specific point. While some of the most advanced theories in physics, like string theory or the cyclic model, play with fascinating ideas of a preceding state or a multiverse, the standard cosmological model presents us with a humbling and mind-expanding reality. The beginning of our universe was the beginning of everything we can measure and define. The start of the story, the turning on of the clock, the unfurling of the canvas of space itself. Finally, consider a beautiful case of cosmic mistaken identity from the history of astronomy. In the mid-20th century, as radio astronomy began to unveil a new layer of the cosmos, scientists detected strange, powerful radio signals coming from what appeared, in optical telescopes, to be faint, unassuming, star-like points of light. They were named quasi-stellar radio sources, or quasars for short. They seemed to be nearby stars, but their properties were baffling. Their light spectra were like nothing seen before, and their brightness could change dramatically over days or weeks, suggesting the source of their power was incredibly small and volatile. The mystery was eventually solved, and the truth was more spectacular than anyone had imagined. These were not stars in our own galaxy. Quasars are, in fact, the intensely luminous cores of galaxies so distant that their light has been traveling to us for billions of years. At the heart of each quasar lies a supermassive black hole, a gravitational monster with a mass billions of times that of our Sun. As vast quantities of gas, dust, and even entire stars spiral into this abyss, the material is compressed and heated to millions of degrees, forming a blazing, whirling accretion disk. The friction and magnetic forces in this disk cause it to glow with such ferocious intensity that it can outshine the combined light of every single star in its host galaxy. We are witnessing the final brilliant cry of matter as it is consumed by gravity's ultimate triumph. What was once thought to be a faint nearby star is, in reality, a beacon from the edge of time, one of the most energetic and distant phenomena in the entire universe, its ancient light finally reaching our eyes after a journey of cosmic epochs. The stars and galaxies we see in the night sky are only a small part of the cosmic story. Most of the matter in the universe is completely invisible to our eyes and telescopes. This mysterious substance, known as dark matter, does not emit or reflect any light. We know it exists because of its powerful gravitational pull. It makes galaxies spin faster than they should and bends the path of light from distant objects. This hidden framework is everywhere, making up the vast majority of matter and silently holding the cosmos together, even though we have never directly seen it. The light from the earliest galaxies has been on an epic journey across an expanding universe. As space itself stretches, it pulls the light waves along with it, causing them to lengthen and redden. This phenomenon, called redshift, transforms what was once brilliant visible starlight into a faint infrared glow. Powerful telescopes like the James Webb are designed to detect this ancient stretched light. When we look at these first galaxies, we are seeing them not as they are, but as they were in their youth, their light softly whispering to us after traveling for billions of years. One of the most mind-bending ideas in physics is the holographic principle. It proposes that our seemingly three-dimensional universe, with all its depth and volume, might actually be a projection of information stored on a two-dimensional surface at its boundary, much like a hologram. This theory emerged from studying black holes, where information seems to be encoded on their surface. While this is still a speculative and unproven concept, it offers a profound reminder that the nature of reality itself may be far stranger and more wonderful than it appears. To our senses, space seems perfectly smooth and continuous, a seamless stage upon which the universe unfolds. However, some of our most advanced theories suggest that at the very smallest scales imaginable, this smoothness might dissolve. Space itself may have a fundamental graininess, like the pixels on a screen or the texture of a fine fabric. This smallest possible unit is known as the Planck length, a scale so tiny we have no way to directly observe it. If this is true, then the void is not a featureless emptiness. Instead, the fabric of reality, from the grandest galaxy to our most quiet thought, is woven upon a subtle, grainy foundation, a quiet structure underlying everything. And so we gently bring our cosmic journey to a close. Let the vastness of what we've explored tonight simply drift around you. There are no more questions to ponder, no more mysteries to solve. Your only task now is to surrender to the quiet. Feel the weight of your body sinking into rest as the echoes of ancient starlight and silent, spinning galaxies fade into the background of your mind. The same fundamental forces that hold the universe together are holding you, safe and secure. With every slow, deep breath you take, let go a little more. Release the day and allow the profound peace of the cosmos to fill the space it leaves behind. The universe has been unfolding for billions of years, and it will continue its slow, graceful dance long after you have drifted into dreams. There is no need to hold onto any of this. Simply let it all go. From all of us here at Sleepy Science, we thank you for sharing this quiet time with us. May your sleep be deep, your dreams be gentle, and your waking be peaceful. Good night.